12. A box has a volume of 5.6 meters cubed. They're going to change it to centimeters cubed. Write your answer in standard form. So they're just playing games here. Okay, so first of all, we have to change 5.6 meters cubed into centimeters cubed. Okay, so the thing to understand is that you may know that there are 100 centimeters in a meter, but when you cube it, you have to think very carefully. And if you've watched the grip videos, this is not the first time that I've discussed this. This does come up. Okay, so it's really important that you start to watch these videos and go back to the ones and just keep revising from them, because it's going to be so useful when you're coming back to it. So, if I think about 1 meter, 1 meter is 100 centimeters. Okay, that's the thing most of you know. If I did 1 meter squared, that would be actually this squared as well, so that'd be 100 times 100 to make that centimeters squared. So that would actually be 4 zeros, 10,000 centimeters squared. And if I did 1 meter cubed, I'd have to cube this 100, which would be 3 of these. So that's one with 6 blooming zeros. So if I've got, that was 1 equals that. If I've got 5.6 of them, that'll be 5.6 million centimeters cubed. So you can see I've got the 5 under the 1, the 6 under the 0, and it leaves 1, 2, 3, 4, 5 zeros after. Okay, and then it wants me to turn that into standard form. So the decimal point's on the end. It needs to move here. So it's going to be 5.6 times 10, because that's standard form. And that would have to move 1, 2, 3, 4, 5, 6 to do that. Okay, so normally, year 11, it's just convert that into that. And that's pretty much the same as normal. The extra bit is to turn the actual answer into standard form, which is not usual. Okay, so again, a weird question for you. But if we're learning all these weird little questions, you will be much more able than your previous year 11s at tackling things like this, because before it didn't always go this way. So in some ways it's a pain, but in some ways you're becoming stronger mathematicians. Okay, right, question 13. Two cylinders A and B are mathematically similar. Okay, that means there is, as this gets bigger, so like it's in the same proportion basically. That is a model version of that. Okay. The base of the cylinder has a radius of 3. The base of the cylinder has a radius of 6. The surface area of B is 400 centimeters squared. Work out the surface area of A. Okay, so we know that the surface area, that's the key thing here, it's the surface area. That's what we're trying to figure out. But we have to start with the lengths of these radiuses to get a relationship. So from here to here, let's go to there, we'd have to divide by 2. Okay, so on the length relationship, will divide by 2. For the area relationship, area is defined in squared units, so we'd have to divide by 2 squared. Okay, so for the area similarity, we'd have to divide by 4. So if the surface area of this is 400, we'll do 400 divided by 4 instead. So the surface area is actually 100. It is not 200, because you don't just halve it, because you're dealing with areas, just like the previous question, where you have to be careful with your units and so on, with volume, area and volume units. You have to be really careful. This is the same thing. Okay, so the volume of shape A is 90, so the volume for this one is 90. Work out the volume for B, so work out the volume of this. So that's the 3D area that it takes up, the 3D space it takes up. So to go from A to B, the length you times in by 2, the area you times by 2 squared, and the volume you times by 2, my brain's thinking about cubed, 2 cubed. So the volume is 90 times by 2 cubed. It's a scale factor cubed. So 90 times by 2 times 2 times 2. 2 times 2 is 4, times by 2 is 8. So 9 times 8 is 72 with a 0, so it's 720 centimetres cubed. Okay, they are all right, and you think you're going to be involved in formula and stuff, but you don't. It's just understanding the relationship between the scale factors for length, area, and volume, where length is just the relationship between the two numbers, area is that relationship squared, and volume is that relationship cubed. So it's all about understanding this idea, and if you can, it's a nice, easy, doable topic. Okay, next one. Here's a table showing data about the heights of some heights in meters of some trees in a forest. There are 160 trees in the forest, so that is the total. Okay, that's the total amount of people there, or the total amount of trees there. Draw a box plot from this information. So a box plot, very roughly, is the lowest value, the highest value, the median, and the lower quartile and the upper quartile. So I need 5 pieces of information to draw this one. So I have the lowest score, which is 5. I have the lower quartile, I have the median. So I've got that, and I've got, well, I haven't got these two. Only got the interquartile range and the range. So I can't draw it until I find the upper quartile and the highest value. So you've got to do a little bit of thinking here. The range is the biggest number, take away the smallest. So biggest take smallest. So 25 equals the biggest number, the one we're after here, the one we don't know, take away our lowest score, which is 5. So something equals 25 equals something take away 5. So you can just do a little calculation there. You can add 5. So the biggest value is 30. So I know that that's going to be 30 now. The interquartile range is going to help us get the upper quartile. So the interquartile range is the upper quartile, take away the lower quartile. We know the interquartile range is 10. So something we don't know, take away the lower quartile, which is 15, is 10. So I can do a little bit of calculation here. So we could have 15. So the upper quartile is 25. So I had this from the data. I did not have the upper quartile or the maximum value. So that's where this information was used to get the things I was looking for. And that is a double whammy one, really. Sometimes they give you everything except like the upper quartile, so you have to do this. Sometimes they give you everything except the maximum value like this. It's not always that they do 2 things that are missing. So to draw this, you need to get yourself a scale on the go from here. So let's have a look. It's going up to 30. How many boxes have I got? So whole boxes 1, 2, 3, 4, 5, 6. So I can do it. Go up in 5s. So I'm just going to start here. I'm doing a different colour because it's difficult to see. So 0, 5, 10, 15. I like to do the notches as well, so you can see the notches there. 20, 25, and 30. So you've got to have a scale, otherwise you can't draw it. Such an awkward, because it's so dark, it's awkward. I imagine it's going to be awkward for you. So lowest score is 5, so we need to do a little line above 5. Okay, so one above 5. Our next one, lower quartile, is 15. I'm just trying to make it obvious for you. In an exam, this would be really light paper, and your pencil would show through dead easily. Median is 18. Okay, upper quartile we figured out to be 25. Just trying to shade it a bit more. And the maximum value is 30. Okay, so they're my 5 pegs. The middle 3 make your box. And then you just draw a line through the middle, like that. Okay, so that's the box plot. Okay, so it says how many trees are over 25 meters in height or tall. So this is where 25 is, right here. Okay, at the upper quartile. So how many are over the upper quartile? It is the upper quartile. So it's the top quarter of the information. Okay, so a quarter of the information, which is here, will tell you how many are there. So it's a quarter of the total amount trees in here, it says there are 160 trees, so it's a quarter of 160, which is 40. So 40 trees. Okay. Estimate how many trees had heights less than 10. So 10, it's right there. Oh. Should be reading the numbers at the same time, really, should I? So 10. What should we say? So 10 is sort of in the middle of the lower quartile. This is the lower quartile here, because that's the lower quartile down to the beginning. So this is a quarter of them. So it's in the middle of a quarter of them. We know a quarter of them is 40 of them. Okay, and it's half of that. So there's actually 20 trees that are less than 10. So it's 20 that are less than 10. Okay, and it's just about understanding that this is one of the quartiles, and it's half of that, and a quarter of each of this piece of diagram is 20. So that was 20 from there to there. This little bit here is 20. This bit here is 20, and that bit was 20. Okay, and that was half of it. Okay, so it's truly just testing if you understand box plots and understand it's done in quartiles or not. Okay, so let's have a look. Ben says that to find 10% of a number, you divide by 10. David says then to find 20% of a number, you divide by 20. Is he right or is he wrong? Okay, so you've just got to show some examples, really. So if you divide by, so Ben says that if you divide by that, right, so divide by 10. So let's see if that's right. It is right, isn't it? If you divide by 10, you get 10%. So for example, 80, 10% is 8. You have to divide by 10. Okay. 20%, if we had that idea, 20% would be 2 of these. So we know that 20% would actually be 16. But if we follow what David's saying, he said to find 20%, he says you divide by 20. So if I divide this by 20, we get 4. And you can see straight away, look, that it's not the same. So you can't just divide by the percentage and get what you want. Okay, so if you divide by 10, you get 10%. If you divide by 20, you get a lot less. So you can see that right there. Okay.